This video is brought to you by Sporlan, quality, integrity, and tradition.
Well, it's Saturday, August 30th. It's about 4 p.m. Got an emergency service call on a walk-in freezer not working. And I can see that this coil is all frozen up. Let's have a look behind. And you can see that we've got a nice iced up walk-in here. Evaporator, walk-in freezer evaporator. So the first step we need to do is go up and inspect the defrost clock, see if there's anything funky going on up there. And then we got to shut the system down and get all this ice melted on it. Trying to make the most of my time, I grabbed my 4-foot ladder and both my hoses because I know I'm going to need hoses to melt everything. Again, I came out actually to get a battery because my meter has a dead battery, but while we're out here, might as well be efficient, right? And grab everything that we might need, or at least that we can hold right now. But yeah, let's head up to the roof and see what's going on up there. My refrigeration rack is right here. Walk-in freezer compressor is going to be right there. This guy right here, and it's off at the moment. Interesting. It's really, really hot too. Okay. Oh, there it goes. It just restarted. All right. Well, everything about that's pretty irrelevant at the moment because if it's frozen up, we got to fix that problem. So, let's see. Walk-in freezer system B, and that's gonna be this one right here. So the time is accurate on the clock, 4:45-ish. So we're good on that. So the clock is keeping time moving. Let's go ahead and bump it into a defrost and see what it does. They did just get a food delivery today. Looks like it's going into defrost. Let's see if it stays in defrost. And then we're gonna grab, so compressor just shut off. We're gonna grab the meter and test some voltages at this meter at this clock real quick. All right, so we got this guy right here, okay? And let's go ahead and go from 1 to N. 1 to N, 201 volts. That is a good sign. That means that we have 201 volts going to the clock to power it, okay? Then we're gonna go from N to 4. That is the refrigeration circuit. It's in defrost. We should have no voltage, that is correct. And then into 3 is our heater circuit. So we have 201 volts going to the heater circuit right now between 3 and N. And it's not popping out of defrost immediately. Okay, that's a good sign too, because if it was a bad defrost termination, that could be a problem. So if we look at this clock right here, 3 and N is my heaters, okay? N is one side of power, line 2 essentially, right? And then 3 right here is the switched leg to the heaters. So we have power at 3 to N. This switch right here is closed, bringing power from 1 over to 3, sending it down to the heaters. So that's a good sign. And we've de-energized 4, which is the refrigeration. So if you look, 1 comes over, goes to 2, and there's a switch there. That switch is open and that is correct right now. So that's a good sign. Defrost seems to be working. Next, we're gonna go ahead and put our meter on current, and we're gonna sense current, and we have no current right now. Yet we're sending voltage downstairs. That is not a good sign. We should have current. We're sending 208 volts downstairs and we've got no current. That is a bad sign. So let's go in to 3, 201 volts. So we have 201 volts going to the heaters, or to the evaporator coil, we should say, and something is not allowing the heaters to come on. So let's head downstairs and go look at the electrical section and see what we find down there. This is our schematic right here. This is the one that I believe we want to be using. Condensing unit, terminal board, yep, 208. Yep, okay. So first off, we put the unit in defrost, the evaporator fan motor's turned off. That is proper operation because they are powered from the number 4 wire. Look at that, freaking icicles hanging down. That seems safe. But it's powered from the number 4 wire for the fans. So that's good sign that both the fans shut off when I put it in defrost, okay? So we come over here and we're wondering why the heaters aren't working, because we should be sensing current up on the roof and we're not. At least we don't think we are, right? I don't think there's a defrost contactor. No, there wasn't. So we need to test to see if we're getting power down here. So we can test at 3 and N down here. So let's do that real quick. That should be in here. I'll get on 3 and N and see what it tells me. All right, so we need to get on, or not. That's there. That's a pain in the butt. Doesn't want to grab onto anything. All right, well, we can just go right here. Let's go to N and 3. So that's N right there, and that's 3 right there. We have 201 volts. So we're getting power to the coil, but the heaters don't have current. Why? And I'll just double check it. This guy on the heater, and we've got no current on the heaters. Okay, so we need to go back to the schematic and figure out what's intercepting the power going to these heaters. Or do we have 3 bad heaters? The odds of that is pretty slim. So more than likely something's intercepting the power. So if we go back to this schematic and we look at 3, power comes off of 3, runs down, over, on a yellow wire, and then it goes through this guy, HL. And then it goes all the way over, and then goes to one side of the terminal board that sends power to the heaters, and then the other side comes back and goes to line 2 on N, right there. There you go, okay? So we need to figure out what HL is. So let's come down here. HL is heater limit. So there's a limit switch back in here. So we have a couple limit switches. You have a fan delay, defrost termination switch back here, which is a 3-wire, kind of hard to see. And then you have a heater limit that's yellow and white. So if we come right here, yellow is right there and white is right there. So let's test power between those and see if we have power between yellow and white. All right, so white is on H1, yellow is on 3. We've got 166 volts indicating that the limit switch is open. Now, that's a switch. So if the switch was completely open, we should read the potential difference, which would be 201 volts, but we're not. We're reading something lower. And what that's indicating to me is that the switch itself is making intermittent contact. Now, that limit switch is encapsulated in ice right now. It's all frozen up. There's no reason that that limit switch should be tripped. That limit switch is a temperature sensitive device that's mounted to the side wall back behind this electrical. And when it gets too hot, it shuts off the heaters, doesn't allow them to run, indicating maybe that there's a problem. But clearly it's not too hot, okay? So we have a failed limit switch. It's a high limit switch. Now what I'm gonna do is we can go ahead and bypass that temporarily to get us up and running. So I'm gonna go shut off power. We're gonna get this coil defrosted. Then we will temporarily bypass that limit switch until we can get back out here and replace it. All right, now personally, I remove the fan motors. So that's what we do at our company, is remove the fan motors, because the odds of them getting wet is pretty high and we'd rather not create more problems. So we just pull the motors out. Sometimes you can bend them out like that. Sometimes you gotta pull them completely. We're gonna get it all defrosted, power's off. And I use this guy right here because I can control the flow on shower. It's awesome. So sometimes I use a big wand, but for the coils, I typically use this guy. And we'll just defrost it, watching the drain, making sure it doesn't overflow. Lovely, it started overflowing out the other side. That's great. Why is it doing that? Because the coil's not level. It's not even close to being over here, and it's pitching that way. That sucks. All right, well, that's what I was trying not to do, was get water on the floor. All right, well, we're gonna let it drain for a minute. That's crazy, I didn't realize this thing was so unlevel. It could be because they shoved boxes underneath and bent the drain pan. All right, got me a pan to go underneath, just in case it overflows again. This way, we're hoping we can prevent any water from going on the ground or getting all over their floor and stuff. So, all right, water's drained out of that side. I'll make sure I watch that side. I never realized this thing was this unlevel. That's crazy. Most of the time we can do this all from the front. As long as you have hot water and it steams, it'll usually wash everything off the back. All right. Wow, that's crazy. It fills up fast on that side. There's nothing on this side. Very interesting. It looks like, yeah, there's a screw in the back. Yeah, it's screwed. Is it really that unlevel? I bet you they bent the drain pan. That's what I bet happened. Oh, I can see what's wrong with the limit switch right there. It's swollen out. We're gonna put the screws back in there. But we're gonna pull the limit switch out. We'll take it with us. So the limit switch itself is all swollen. So it's no longer making contact inside, just intermittently. So it just got water and moisture in there, and then it froze and popped the little plug out, and it's not making contact anymore. Not a race when we're doing these. You just got to get it done and get it done right. Get all the ice out. So I prefer to try to do it from the front, so that way we don't make a mess, because coming from the back side is just going to make a mess. And this is a raised floor walk-in freezer, so we really don't want to get water on that floor if we don't have to. It's funny, the kitchen manager, I don't think he understood my sarcasm, because I told him this was my fault because I went out to lunch with my wife when we were heading to lunch. And then the service call came in. And he's like, what? And I'm like, it's because I left my house. If I'd have stayed home, I wouldn't have gotten any calls, but it's because I left my house. And he's like, oh, okay, I get it. I was like, I'm being sarcastic, dude. But isn't that the truth? When you're on call, if you stay home, sometimes nothing will come in. But if you go out and do something, that's when you get disappointed. Almost defrosted. Just the bottom. Okay, we're done on that side. I'll get back here real quick. I think that's already almost defrosted. Yeah, we're good. Also, when we change limit switches, we change them as a set. That's how I do it. So if this one's bad, we're changing the 3-wire too, so we're getting them both. The heater safety and the 3-wire defrost termination. Do them both at the same time. That way they're the same age. All right, from what I can tell with my hand, it seems all defrosted. Let's go ahead and put you guys back here and see what it says. So you guys are seeing this before me. That's one side, and then that's the other side. I think we're all good. I'm gonna review the footage, but like I said, you guys saw it before me. Also went over here, got everything up in here. So we're gonna get this put back together and get it turned on. Super stoked. I ended up having these in my van, both of them. Like I said, we changed them as a set, so that's awesome. So I'm gonna put these in, and then we'll turn it back on. It is tight to get these things in. You have to use that 6-in-1 that's very shallow on the outside of the nut driver, because standard nut driver won't fit. The screws are too close to the limit switches on these. It's always been a pain to get these things in. So it looks like this limit switch closes at 40 degrees. Looks like it opens at 75 degrees. So there's no way it was 75 degrees when it was encapsulated in ice. When it was encapsulated in ice, it would have been 32 degrees. Or pretty darn close to it. Okay, so those should be flush against the wall like that. And then just bring all this over here and we'll do all the wiring over here. Need to get a new drill, their impact or whatever. I finally worn this one out. The rubber's gone, the trigger's like really touchy. It's time. All right, so now I'm just going to do the wires wire for wire. I'm actually going to move a few things and sit my butt up on this shelf so that way you can actually see what I'm doing. Alright. So with that being said, this guy should be coming down white going here. I mean, the colors don't really matter on the heater safety. The colors definitely matter on the fan delay defrost termination. So don't mix those up. Yellow goes up to 3. Okay. So that's that. There we go. That's good. And then now, red, brown, and black are going to come over here. So, brown is going up to X. That is our defrost termination wire. If the coil gets too warm, it sends power through the X wire up to the defrost clock and terminates defrost. So in theory, if it was too hot for the limit switch to put the evaporator into defrost, then it would have kicked it out of defrost, because the fan delay defrost termination would have also sensed the same heat. But because it wasn't doing that, that's what made me start to come down here and look at these limit switches. So when I put it in defrost and it stayed in defrost, but it didn't have any current, I knew something was wrong. Okay, so black is going to come over and go to F1. There we go. So black will come around and go to F1. All right. And then last but not least, red will come up and go to N. Get that up there. And then red comes up here and goes to N. All right, we are wired in. So, now with that being said, when we turn this on, these evaporator fan motors should not turn on immediately. That is a good sign. There should be a delay until the coil gets to 35 degrees. The surface temperature of the wall right there gets to 35 degrees, then it turns it on. We better test the heaters actually. So We're gonna do that real quick. We're gonna put it in defrost and then we'll let it terminate out. And we'll test the heaters to make sure they're actually working. So I had to turn it in refrigeration mode because it's actually too warm for defrost right now, because the limit switches are still warm. But it's in refrigeration mode and the fans aren't running. That is a good sign. The coil has to get cold enough before the fans will turn on. And they're sensing the surface temperature up where those limit switches are. Oh, there we go. Evaporator fan motors are running. So we'll let it run for a minute, cool the box down for a minute, and then we'll put it in defrost and test the defrost heaters. I let it run for a few minutes, then I put it in defrost. Now we're getting 6 amps. So let's head downstairs and check the heaters, make sure they're all working. All right, so turn that stupid light off. Drain pan heater has 2 amps. And then it looks like we've got coil heater has 2 amps. And then it has another coil heater right here. 2 amps. So all the heaters are pulling current. 2 amps seems sufficient. We're gonna put all the covers back on and put this guy back into freeze mode and let it start bringing all their ice cream down to temp because they probably lost it all. We'll see. All right, back up here. For us, 4 defrost for a walk-in freezer is typically enough. It's gonna change regionally, but 4 defrost for a half an hour is more than sufficient typically for what we're dealing with. Occasionally, we might throw an extra defrost, you know, like at 5 in the morning for a half hour like that, but that's pretty darn good, okay? Because that's on the inside of a walk-in cooler. They're pretty good. Now, come over here. Compressors right here. We do have oil in the oil sight glass, so that's a good sign. And then over here, we've got a Sporlan C all over there, and that should be clear. I'll give it another minute just to make sure it stays clear, but the evaporator fan motor should be running right now. I don't see the need to put on service gauges because this box was iced up from top to bottom on the coil, left to right, the whole coil. To me, that doesn't indicate a refrigeration problem. That indicates an electrical defrost problem. So don't see any need to put service gauges as long as the sight glass is clear. We'll come over here one more time just to make sure. And it is. Sight glass is still clear. It's 404A, no need to put service gauges. We're good. We'll take a look at the condenser coil over here just for giggles, because it is a really hot weekend. It's about 105 today, I think. Condenser for the most part is pretty clean. We just did a coil cleaning on this, so the guys just cleaned it up. So I'm pretty confident with that. When we have these emergency calls, you kind of don't know what you're walking into. But they did give me some feedback on the work order. It said that the evaporator fan motors were running. So that to me indicated power was on of some sort. And when I got here and I found that it was iced up, I kind of already had a hunch in my head, right? Put it in defrost, no heat, I kind of already had a hunch because I know that there's a limit switch there. For the sake of the video, I went through the schematics, showed you guys how we diagnosed it, and we came to the conclusion. Now, I didn't think that I had one of those limit switches, but when I ran out to my van, I just grabbed it into my parts drawer, and sure enough, I had a fan delay, defrost termination, and a heater safety because, like I said, I change those as a set every time. So if I have a defrost termination, they get a new, that's bad, they get a new heater safety too, okay? That's how I typically do it, just from my experience, okay? So we were able to defrost the coil, we were able to put new limit switches in it, verify that the heaters are working, the defrost clock had the right time, which that was a very important thing too, is that when I walked up, all the defrost clocks inside the cabinet had the same exact time and it was all correct. That is a great indication that the clock is keeping time, okay? So obviously this one just wasn't getting the proper defrost because the heater safety switch was bad. More than likely moisture got in it, froze it, expanded it, caused it not to work anymore, okay? So why is there ice though? Because that's a walk-in freezer. We're maintaining -10 degrees box temp in that box. That coil is well below freezing when it's running. So naturally, if the coil gets below freezing, frost and ice is gonna start to accumulate, okay? So we have to have a defrost. Now, air defrost wouldn't work on a freezer. It has to be electric or hot gas because air defrost, you're gonna be what? Blowing -10 degree air across that ice? That's not gonna do anything. So we use electric strip heaters and we energize them for a period of 30 minutes and or 55 degree coil temperature. So if the defrost termination sees 55-degree coil, I think it's 55, I think that's what I said. But if it sees 55-degree coil temperature, then it terminates defrost. So it's time or temperature terminated, okay? So we know that the system is doing everything. Now, I mentioned in the video too, I don't see the need to put service gauges on here because it doesn't seem like a refrigeration problem. When the evaporator coil is frozen top to bottom, left to right, solid and evenly, to me, that's a defrost problem, okay? So I'm taking the chance by not putting service gauges on this guy, simply because I see a clear sight glass. The customer said it just happened today. Everything else has been good. So that's it. I really appreciate you making it to the end of the video. If you haven't already, please consider subscribing to the channel. We just passed 200-something thousand subscribers, which is really awesome. Thank you very much for those of you that are subscribed. And if you aren't, hit that subscribe button. Helps the channel to grow a little bit more. Leave me some feedback down in the YouTube comments. If you're interested in supporting the channel, the easiest way to support this channel is just watch the videos from beginning to end. That really is the easiest way. But you can also support it monetarily if you want to. You can go to PayPal, Patreon, YouTube channel memberships, all different ways that you can support it. You can also go to my website, HVACRvideos.com, where we have hats such as this one available. And last but not least, you can go to TruTechTools.com. I pick up a good majority of my tools from them, such as the SC480 field piece meter that I have in this video. I picked that up from TruTech. I happen to have an affiliate code set up with them, or affiliate program set up with them. So if you use my affiliate code Big Picture, that's one word, Big Picture, at checkout, on majority of the items, you'll get a discount. And when that discount is applied, I get a small commission also. So another great way to help support the channel, okay? Thank you very much. I really, really appreciate y'all. Leave me some feedback down in the YouTube comments. Oh, and last but not least, if you want to go PayPal, Patreon, or YouTube channel memberships, there's links in the show notes of this video to all those, okay? Thanks so much, and I hope to catch you on the next one.